So section 12.6 is all about the surface area of spheres. 13.3, volume of spheres. Open up your notebooks, get this into your table of contents, and then we'll begin. Now, in order to talk about spheres, we first have to have a firm understanding of what a circle is. The textbook definition of a circle is the set of all points in a plane that are the same distance away from a given point. A sphere is essentially the same thing. However, we lose the phrase set of all points in a plane, and instead we have the set of all points in three-dimensional space that are the same distance away from a given point. So that is our definition for a sphere. The surface area of a sphere is 4 times pi r squared. The volume is 4/3 times pi r to the third power. Please note that the difference there, right? In surface area, it's 4 pi r squared. With volume, it's r to the third power. So some other vocabulary for you to get down. The great circle. So a circle on a sphere where the center is the same and the radius is the same as the sphere. You'll notice in these two smaller circles, their radii are much less than that great circle, right? So the great circle is essentially the largest circle on a sphere. And that radius is going to be the same. The radius of the great circle will be the same as the radius of the sphere. And then also we have a hemisphere. Hemisphere is just half of a sphere. So in order to understand the great circles thing, if you think about lines of latitude and longitude, so latitude are, for example, the equator is a line of latitude. The Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, all of these are lines of latitude. And they are not great circles. The equator is, but all of the other lines of latitude are not. However, the lines of longitude are great circles, right? They're the lines that run north and south. They go through the North Pole and the South Pole. Those are all considered great circles. And then, of course, hemisphere. If you cut a circle in half, you create a hemisphere. Again, if you think about the world, you think about a globe, we have the northern hemisphere and southern hemisphere. Or if you cut it differently, you can have the eastern and western hemispheres. Now, volume and surface area of hemispheres. First, recap. The volume of a sphere, of course, is 4/3 pi r to the third power. And so if we want the volume of a hemisphere, surface area as well. So volume of a hemisphere will just be half of the sphere. So we'll take half of 4/3 pi r to the third power, and half of 4/3 is just 2/3 pi r to the third power. So that's the volume of a hemisphere. Surface area of a hemisphere, it's tempting to just cut 4 pi r squared in half. It's tempting to do that, but that would be incorrect. And here's why. To find the surface area of a hemisphere, first let's just picture ourselves a hemisphere. We've got this sort of dome shape. Now, the typical mistake would be to just take the surface area of a sphere and cut it in half. However, the problem with that is, let's turn off the X-ray here. If I just take the surface area of a sphere and cut it in half, then I'm missing this bottom circular sort of base or footprint. And so instead, we actually have to show that, that circle as a surface. So yes, we're going to cut the sphere in half. So we're going to cut 4 pi r squared in half. But then we have to add in this circular base. So that will give us the surface area of a hemisphere, right? It's kind of like lateral area would be the dome shape, and then a base of one circle. And so when building the surface area for hemispheres, well, we already found the volume in the previous. So the surface area of a hemisphere is the dome, that circular dome, as well as the circular base. And so the dome is just going to be half of the sphere, and the circular base is the area of just one circle. So half of 4 pi r squared plus pi r squared, which gives us 2 pi r squared plus pi r squared, or even more simply, 3 pi r squared. So that will give you the surface area of a hemisphere. So let's just recap. We have the surface area of a sphere, we have the volume of a sphere, the surface area of a hemisphere, and the volume of a hemisphere. So let's practice a couple of problems. This first one, take a look. We want to find the approximate surface area of a sphere with a great circle circumference of 18 millimeters. It's sometimes helpful to sketch a sphere, which is a little bit difficult to do. What you can do is start by drawing a circle and then draw an oval or an ellipse as kind of a belt around that circle. Now, we want to find the approximate surface area, and so we're using 4 pi r squared. We know the circumference of the great circle, so that's 18 pi. Sorry, not just 18, not 18 pi. And so we can extract the radius from the fact that the circumference is 2 pi r. So 18 divided by 2 pi will get us our radius. So that radius, it simplifies here to 9 over pi. And now we can use that information in our surface area calculation. We have 4 pi r squared, so 4 times pi times 9 over pi squared, which is 4 times pi times 81 over pi to the second power. And that simplifies to 324 divided by pi, which is approximately 103.1 square millimeters. Next example problem, we want to find the volume of a sphere with a diameter of 8. Well, just once again, we want to find the exact volume, so we're using 4/3 pi r to the third power. And we know the diameter is 8, and that tells me that the radius is half as big, so the radius is 4 centimeters. And then all that's left to do is sub in 4 into our volume formula. So we have 4/3 times pi times 4 to the third power, and 4 to the third power is 4 times 4 times 4, which is 64. And then I'll multiply 4/3 times 64, and so we get an exact answer of 256 over 3 times pi cubic centimeters. Remember, when you're measuring volume, it's cubic units of measurement. Here's another example. We want to find, what do we want to find? A hemisphere has a surface area of 192 pi. What is its radius? So first, we have to figure out what we're dealing with. We're dealing with a hemisphere, so half of a sphere, and we know its surface area, and we want to find the radius. So recall, the surface area of a hemisphere was 2 pi r squared plus pi r squared, which simplifies to 3 pi r squareds. And then all we have to do is use that formula and work backwards to find the radius. So we have 192 pi equals 3 pi r squared. We'll divide by 3 pi, and then we'll square root both sides to get a radius of 8 centimeters. Here we have another example coming up. A sphere has volume 166 and 2/3 pi cubic units, and we are asked to find the area of the great circle. So area of the great circle, remember great circle has the same radius as the sphere, and area of any circle is pi r squared, and so we need to use that volume information to extract the radius. Remember, volume is 4/3 pi r to the third power, and we have 166 and 2/3 pi, which, if you change that mixed number to an improper fraction, that's 500 over 3 times pi. So that's our volume, and we want to solve for radius. So first we've got fractions, divide by 3 on both sides, so I'll multiply by 3 on both sides. and then I'll divide by, well, I want to isolate r, so I'll divide by 4 pi. And that gives me r to the third power is 125. And so if you take the cube root of 125, that gets you a radius of 5 units, and so the area of the great circle is 25 pi square units. We have one more example, and it's kind of a doozy. We want to find the volume and surface area of this thing. It almost looks like a pencil. So we have a cone attached to a cylinder, which is also attached to a hemisphere. So let's first look at volume. We want to find the volume of essentially these three separate pieces, the cone and the cylinder and the hemisphere. So recall this, the various pieces for that formula. The cone is 1/3 pi r squared h, the cylinder is pi r squared h, and half of a sphere would be 2/3 pi r to the third power. Now we know that 4 centimeters represents the diameter of the circular base, and so the radius then would be 2. We also need the height of the cone. Now the height of the cone, if you look at the triangle made up of the height, radius, and slant height, we know 2, and we want to find the height. And so that would be an opposite and adjacent. We'll use the tangent formula to find the height. So the tangent of 24 degrees is 2 divided by h. So the height is 2 divided by the tangent of 24. So whatever that would be. Then we have all the information we need. We know the radius is 2. The height of the cone is 2 over the tangent of 24. The height of the cylinder, that's just given to us as 10. And so we're just going to sub in all of these numbers into our formula and start punching numbers on the calculator. So the volume of the cone is about 18.816. Add the cylinder, which is 40 pi, plus the hemisphere, I made a little mistake there, should be 16 over 3 times pi. You add those three together and you get about 161.235 cubic centimeters. So there's the volume. We also want to find the surface area. Now surface area is going to be a little bit different because we can't just add surface area formulas. We need to be a bit more strategic. So I know I have the lateral area of a cone. I also have the lateral area of this cylinder. And then I have only the dome of the hemisphere. And so instead of 3 pi r squared, it's just going to be 2 pi r squared, because that circular base is sort of stuck onto the cylinder. And so we've got our formula, pi r times slant height plus 2 pi r squared, 2 pi r h plus 2 pi r squared. Let's see, we need to find the slant height, and so in that same triangle in the cone, we know the slant height can be found using the sine formula. So sine of 24 is opposite over hypotenuse, and so the slant height will be 2 over the sine of 24. Again, whatever that is, plugged into your calculator. And so now we have the lateral area of the cone. We want to add the lateral area of the cylinder plus the dome shape of the hemisphere. And so the cone is about 30.896. The cylinder is 40 pi. The hemispherical dome is 8 pi. Add all those up, and you get about 181.692 square centimeters.